Quick question. If I told you your Python code might be running 50 to 100 times slower than it needs to be, and the only reason is a for loop, would you believe me? Because today I'll show you two pieces of code that do the same thing and one absolutely embarrasses the other. By the end of this video, you'll understand why for loops are slow, what vectorization actually means without the math pain, and how NumPy silently turns Python into a performance monster. Even if you're a beginner, this will click. Imagine this. You're asked to move 10,000 boxes across a warehouse. Option A, you pick up one box at a time, walk, drop, repeat. That's for loop. Option B, you load everything onto a forklift and move it all at once. That's vectorization. Python for loops are you walking back and forth with one box. NumPy vectorization is the forklift. Same task, wildly different speeds. And the crazy part? Python looks like it's doing the work, but it's actually terrible at it. Python is slow at loops because it checks types every iteration. It jumps between memory constantly. It runs instructions one by one. NumPy doesn't. NumPy hands the entire operation to compiled C code under the hood, which runs close to hardware speed. You write one line, NumPy does the heavy lifting. Let's see this in code. Now watch this carefully. On one side, we have the classic Python for loop. It goes through the array one number at a time, adding each value to the total. On the other side, we have the vectorized NumPy version. One line, same operation, no loops used. Both pieces of code do exactly the same thing. They sum 10 million numbers. The only difference is who does the work. In the for loop, Python is in charge. In the vectorized version, NumPy hands everything off to optimized C code under the hood. So let's run them together. Here you have it. Same data, same result, although completely different speeds. This isn't just about being fast for fun. In AI and machine learning, your data is huge. Your training loops run millions of times. Inefficiency compounds brutally if your pre-processing uses Python loops. Your model might be slow before training even starts. And no optimizer will save you from bad fundamentals. Here's the rule you should remember. If you're looping over numbers in Python, there's almost always a vectorized NumPy way. Loops describe what you want. Vectorization lets the machine decide how to do it fast. This is why NumPy shows up everywhere in serious code bases. Not because it's trendy, but because it forces you to think in a way machines actually understand. If this changed how you think about writing Python, that's the real win. Thank you, and follow for more.